Hey y'all, it's been a hot minute, but we're back for a little bit of an adventure. So that's exciting. So today we are going to work on an issue that I found with Spark and IPv6 on Kubernetes. Yeah, IPv6 fun. Yeah, a long time since I got to stream. Cool. Okay. So yeah. Okay, yeah, I need to press the code button. That's great. Okay. Oh yeah, and then I need to bring this up. Oh wait, no, I don't need to bring that up there. That's up here. Great. And then we're gonna go over here. Oh yeah, okay. Let's figure out what branch we're on. Okay. Cool. I wonder Git check out me. Oh, I think we're still calling master and spark. GitHub master. I guess we might as well also update this propagate executor loss reason if I haven't. So let's do that. Except every time I interact with Chrome, it just feels like, I shouldn't say every time. Most of the time it's actually quite fine. Let's take a look. Do I have any? Cool. This doesn't seem to be particular in order. Did this get merged, or did it just get closed because we left it out of time? Okay, cool. Dongjun did a fix, merged it, that's great. Love it. Okay, cool. This is probably the first time in a really long time that I have not had an open Spark PR. I shouldn't say, I don't know. Whatever, let's go ahead and fix that. So, let's go, we're going to bring up the ASF Jira for the issue that I just filed. Oh, God. Yeah, okay. Cool. So, yeah. So, okay, this is the issue. The issue is essentially we end up storing one format, but sometimes we go and we try and look it up by another format. And this is because IP addresses can be represented in multiple ways, especially with IPv6, where we can have this : and just like implicitly all these zeros are here. But when we go ahead and expand it out, then we try and do a get on this, it fails. So not an issue with IPv4 addresses where we just represent it classically in one way, but here, all kinds of fun. So, okay, and it's inside of the coarse grain scheduler backend. Okay. add executor so we're gonna refactor this out into RPC address string. RPC address, and then this is probably a nutty thing, I guess, but it could also be internal to Spark. Okay. Yep. So this is a host and a port, and these are actually represented as strings. So, this is problematic. So we need to normalize it at some point. But how do we normalize it? This is a good question. This is a good question. Yes. Okay. Okay. This is a private case class, so we can change it. So that's great. If it was a public case class, we could not change it. But this is private, so we can do things to it, provided that we. Okay. Do I want it to be a case class? Or do I want it to be... Actually, I don't want it to be a... Okay. Yeah. Yeah, I don't love this. Because I want to hook into it, and this is the thing, right? Like, okay. Scala. Some constructor. Well, I guess if this is internal, okay, yeah. Oh, actually, we probably need to keep it as a case class for pattern matching. Okay, never mind. But if it's constructed here, okay. Normalize host. Host is of type string. Okay. Normalize the host name. Normalize the host. For v6 addresses. For v6 addresses, expands everything. Okay. Java normalize IPv6 address. Yeah. Okay. Not what I want. Something tells me that we don't use this IP address. Repo. Oh, here we go. INET 600. Okay, actually, I want to see where else we're using this RPC address. I want to see how we're, because I know in the case that I've encountered it, the host name is always, it's always resolved as an IP address, but maybe this is going to be resolved as a host name somewhere. So let's go ahead and take a look. Yeah, so here we've got localhost and a bunch of different sweet shit. Okay, so I guess what I'm wondering is, like, behavior-wise, like, so for example, localhost 1 and localhost 2 are both going to point to different, like, let's go take a look at master suite. Okay. Yeah. So yeah, we don't want to resolve it to from host name to IP address. Hey Nova. Normalize host. So I guess really, actually, yeah, let's do this here. We actually probably want to put this inside of a utils class. Okay. Okay. So we're going to put it here. Normalize IPv6 IPs. Normalize IPv6 IPs. And what's this? Add brackets if needed. Let's go take a look. Add brackets if needed. Okay, I guess to match that, what we'll do if host dot starts with I would, yeah, chicks with 6. Yes. Okay. So then, what are we going to do? We need to... Yeah. Okay, so here's where we need to... Actually, wait, yeah. So here we know we've got IPv6 in theory. So... oh yeah, I guess we're going to move this over here. Oh, I guess we already import java.net, so that's great. There's a v6 address. Okay. So, what's the constructors for... Let's get address. I don't want to do that. I want to just construct a v6 address, but it's not... I don't... This is... Yeah. This extends this, so... This requires that I have it as bytes. Hi, AK. And I would rather not parse it into bytes. I want it to take a string, but not a host string. I'm lazy. Get host address isn't quite what I want. Yeah, also not what we want. Okay. Lava is half of... Yep. we still depend on Guava? That's a great question. Yeah. Yep, looks like we do. Oh, and actually that's where we're importing INET addresses from. Okay, cool. Oh, we are already using it. So, okay. Okay. Cool. Okay, for string post. Actually, the other question is add brackets if needed used anywhere else? Because if not, we can just it looks like it is. Okay. INET address, string for host. Yeah, so the reason that I'm using IPv6 here is essentially there's like limited IPv4 address space, and Spark has a lot of IPs, and so Spark uses a lot of nodes, and when we're like bringing them up and down dynamically, and we have like super large numbers of nodes, it's just better to use IPv6 addresses because we have a limited amount of free IPv4 address space. Okay. And then the question is toString going to give us... no, I don't want the host name. Let's go take a look at toAtterString. Ah, yes. Main difference is here. This uses doot for zero compression, while Java's version uses the uncompressed form. Okay. Address. Okay. So that's kind of a hack. Now, yeah. Okay. Scala case class override equals. Oh. Why does it say... Okay, I guess let's switch it down to... Oh, I'm super glad, AK. That's really sweet. Let's try dropping it down to a regular case. Sorry, regular class from a case class. Because maybe we shouldn't. But the problem is... Mixed views about this. Okay. Okay. Do not change equals on case class. Yeah. Okay, yeah, so, okay, we've got, like, essentially two options, right? Like, we can override... Oh, yeah. Yeah. So, okay, actually, I guess we've got three options as to what to do here. We can switch this from a case class to a regular class, override equality and hash code. We can keep it as a case class, override our, like, make a new constructor. Okay, let's see what people say about that, because that might be the better case class custom constructor. Yeah, I think it's fine. We can do this. I think this might actually be a better way to do it. Oh, there's a problem with my mic? I could totally see that. Let's take a look at the settings. Properties. Properties are set to default. Okay. What about... Okay, cool. Cool. Yeah. Okay. What can we do here? Oh, right, yeah. Okay, so def this. Yeah, can I do this? Except... Because, like, essentially I want to apply something to it. Maybe, yeah, maybe I should do it with def. Let's do that down here. Post string. Oh, I love tail recursion. I think it's a great way of expressing that logic. Yeah, I love tail recursion. I think it's choice. Although often nowadays I end up writing loops more frequently. But that's because I'm switching between languages which do happy things with tail recursion and languages which don't do happy things with tail recursion. But yeah, I think it's pretty cool. Okay, I don't know if this is gonna work. Let's go. Does this seem reasonable? And I guess the other one is RPC utils, and then oh yeah, I guess RPC address sweep. Okay, this is not going to be the case anymore if we go with this, because we're going to expand out all of the simulation. I guess it's better to not change that behavior in case someone's appending on it. So let's go although yeah. I mean, yeah, so like this is pretty normal testing paradigm. Like it's just, you know, standard assertions. You know, it's pretty great. I think Scala check is really cool. Yeah, I think Scala check is really cool for generated tests. And I think there's something, yeah, so Scala check is awesome. I don't remember what the Python equivalent of it is. But property testing is really rad, and I wish more projects did it. Okay, clean compile, test compile, core, test, only. Probably going to fail. That's okay. But this gives us a starting point to start thinking from. Huh. Oh, okay. Yeah. That's legit. Okay. Course frame scheduler backend. Let's go take a look. Oh yeah, I was going to do that. But here it looks like we can actually probably fix this at a lower level, because like if we normalize the host names when the RPC environment is constructed, or we don't have to worry about or normalize IP addresses when it's constructed, then we don't have to worry about bad news bears. Okay. Okay. Let's go ahead and take a look at this. Host address. Oh, wait. Oh, 2F. Gotcha. This is actually to_attr string. There we go. Love to see it. Okay. Let's run again. Public method must have explicit type. Okay. Oh yeah. I mean, no reason to make this public, I don't think. Cool. And then if this succeeds, what's my next plan? Okay. And if it succeeds, we'll make a PR. I'll drink some coffee. And then, yeah, I mean, we can do that while we're compiling. Yeah. So my understanding of them, which is, possibly off, because I don't actually use hermetic builds, like as we've seen, like here, like using Maven Central and we're dynamically downloading a whole bunch of things. But the idea is that like your entire environment is like sealed or specified, and so like you're not dynamically resolving anything from the internet, and so you're not going to have any like external dependencies on, say, like storage-download.googleapis.com, right? I don't know. I think, and so there's certain circumstances where like you want to be able to do a completely offline sealed build, and then like, so like for example, you take your source code to some machine that's like not connected to the internet, you run your build there, it signs it, because you've got your signing key on that, you bring it off, and then you've got this like nice artifact that you can be like relatively more certain no one has done any bad things to. I don't know how that goes in practice. Okay. Now we're getting to see some of the fun of working with Emacs and SVT, which is to say SVT gets a little bit confused by Emacs's temp recovery files. That's okay. That's okay. Okay. How we doing? One morning. Oh, I mean, that makes sense. Like, the Knicks folks are very, like they take a pretty unique approach to a lot of things that they're doing. Um, so, that, that makes sense. I like simplicity. And so part of that means like dynamically resolving these things is a lot easier. But like on the downside, like I don't really have super reproducible builds because these things are like dynamically resolved from the internet. Especially, I mean, for the Maven artifacts, in theory, the Maven artifacts are immutable. The practice, but like for like some of my Python stuff, like I'm installing from a Git branch, which is very intentionally mutable, and that's just I'm lazy and it makes my life easier. Isn't necessarily the best way to pick stuff, but yeah, that's what it is. Okay. Why is this taking such a long time? But okay. Compile everything. Well, now we're doing the test compile. Oh. Okay, cool. And it fails. Because... Oh, okay. This is not equal to this, of course. So let's go... So, add brackets if needed. If address contains colon, but not brace, then do this. Here, let's take a look over here. So this is, I'm confused how we're getting this, right? Like this, to me, does not make sense. Let's go take a look. RPC address suite. Line 71, okay. Hmm. Okay. If address contains this and not this. Do this. Somehow. Oh. Okay. Yeah. So Spark uses RPCs a lot, and that's because it's running on different computers, and so it sends tasks around. And this RPC environment is, here we go. Here's an exception. This one makes sense. Okay. Yeah. Host starts with and so here, like, yeah, sorry, my brain. Yeah. Okay. Oh. Except actually, let's go ahead and we're going to do this as a Scala RE. Yeah, so actually Spark does use protobufs in some places. Here, like, this is just like doing some relatively simple logic. All right. So this is how I write this regular expression in Python. Perl, maybe, I don't know. Posts. Okay, wait. So this was trying to help me out here, and this is IPv6 address. If they are present, or let's call this unbracketed. Okay, it's probably not going to work, but okay. Invalid escape character. So you are saying that this is not a valid escape character. Oh, right, okay. Right, let's do, because it's, and I'm not trying to escape it as a string, I'm trying to escape it in the RE, so let's go ahead and do that. So we'll do this multi-line string, which also is essentially just like string literal, or not. Yeah. Okay. Let's see how this goes. Solid maybe. Okay. Okay. Here we go. We're iterating on a regular expression here, and so yeah, trying to make it okay. Cool. This looks like it's working. Okay, cool. Now let's add one that would fail if we didn't have this. Probably should have done this in another order. So let's go ahead. We're going to get our Jira number up here. Consistent sparse mapping. Okay. Heck yeah. Magic. And by magic, I mean, I think it's working. This is the RPC address suite, consistent sparse mapping. Great. Okay. This is good. Oh, yeah. IPv6. Yes. Or, I mean, like, conceptually similar, but, like, the way things are specified is different. And like the syntax for an IPv6 address is different than the syntax for an IPv4 address. But like conceptually like similar, like we're specifying like number of bits. We both use what's called CIDRs, which is essentially back in the day. We had like only like 255.0.0.0 or 255.255.0.0 or 255.255.255.0. and those were like class A, B, and C addresses, I want to say. But now we just have like we just specify like the number of bits in either situation, and so you're not limited to class A, B, and C. Okay, I think there we go. Cool. There we go. Okay, actually, so we can test this. Yeah. Whatever. We've already tested it. Yeah, CIDR is fascinating. Anyways, okay. Whatever. Let's do it. Oh, okay. That's the doorbell. I'll be right back. We are back. The doorbell has been dealt with. These problems have been solved. And now we're going to make our PR. Oh yeah. Okay, cool. Normalize IPv6 IP is known for all our hosts. Oh. What's a good intro to IPv6 project? The problem is, like, there's like a whole bunch of IPv6 projects, but most of the ones that exist right now are like kind of gnarly. They, like, from a software standpoint, like, a lot of the easy to migrate ones are done, and now we have the less easy to migrate ones. But like, if you don't already have it installed on your machine, like, I don't know if you have an IPv6 address. If you don't, from your ISP, you could reach out to them and get one. You could also set up a tunnel broker, and you could get some IP address space that way and sort of start playing with it. There. Yeah, okay, yeah. So I would search for IPv6 tunnel broker. You should be able to find a free one, and you can sort of get that set up, and you can, yeah, you can start exploring the wonderful world of IPv6. Okay. What is this? Yeah. Okay. So what are we gonna do here? Yeah. Okay. IPv6 address mapping can fail with sparse addresses. Okay, yeah, RPC address equality can fail with sparse IPv6 addresses. Inconsistent formatted sparse IPv6 addresses. Okay. Oh no, that's not the right remote. Ooh, am I on the right branch? That's a good question. Nope. Okay. Yep. There we go. And then reset origin. Okay. And now we'll go ahead and we'll make this pull request. Cool. Was inconsistently can fail. Yeah. When constructing an RPC address, make the use consistently formatted IPv6 address if the host address. Yeah, so classless inter-domain routing isn't as popular for IPv4 because a variety of reasons, some of which are related to money. And so, like, if you look at the errand fee schedule, oh, so okay, are we talking about the ::mu format or the like mu .o format? Anyways, whatever. Yeah. Sorry, brain. Okay, why are these changes needed? Oh yeah, so the : format. So that's not actually CIDR. CIDR is specifically around which bits are like essentially like what net masks are present in like global routing tables. The : format. I mean, it's just like when you've got like you have like 4 things, right? Writing 0 dot like twice is like pretty chill. God damn it, Siri. Yeah. Why are the changes needed? We use RPC address equality for various tasks involving executors. Okay, let's move this up to. I don't know why it's not working, but that's okay. Okay. For various tasks involving executors and a mismatch of equality can cause interesting errors. Okay, cool. Log messages might change from sometimes having all the zeros in the v6 address present to existing tests plus new unit test showing that : is formatted Okay. Cool. Got a pull request. Fuck yeah. And it has been a little bit over an hour, and so yeah, everything kind of hurts, especially my feet and my knee and my wrists. So yeah, we're gonna take a break. And yeah, yeah. So yeah, I think we'll wrap up. It's almost 5 o'clock. I'll probably be back later. I might do some other stuff. I feel like what time is my next thing? Yeah, okay. Next thing's at 6:30. So I'll take a break and then maybe I'll do a little bit more Python stuff after maybe like 5:30. Do a little bit more Python. Yeah, so I'm gonna screw around some more with the Google Calendar API, probably at 5:30. Not really related to this stuff at all. It's just like personal project dealing with the Google Calendar API is one of those things because I'm frustrated with people scheduling sort of last minute things on my calendar, and I'm also like I have like a non-bidirectional calendar sync set up from like personal to work where I get like certain information, but I want to create more of a bidirectional flow, and the tools to do that cost money. Although I think Clockwise is probably free, isn't it? Let's see here. Some of my coworkers like Clockwise for auto blocking time on their calendar. Is it free? It's free for Chrome. Okay. Yeah, so this automatically blocks focus time, which looks really cool. Yeah. And so like I think having something to oh yeah, I'm not that organized, but I probably should be a little bit more organized. I should work on that. Actually, yeah, I'm interested in this. Let's see here. So clockwise. Yeah. Yeah, I think yeah, having more focus time on my work calendar is something that would also be cool. So I like this. I wonder how they make money. Let's take a look. How do these people make money? Ah, they have a pricing section. This makes sense. Okay, they charge $6.75 per month? Huh. Okay, that's interesting. Well, yeah, whatever. Yeah. Yeah, no, yeah. Whatever. I will, yeah. So anyways, I'll do a thing. It'll be okay. And yeah. Okay, I'm gonna take a break for real now though, cause yeah. Okay, thanks so much for chatting. Probably be back at 5:30 for a little bit. Do some more work. If anyone wants, right now, Adriana is streaming. And her streaming is pretty rad. Let's see if I can do a raid, I guess. There's gotta be... I should know how to do this. Well, let's see actually if we have any viewers on Twitch, or if everyone watching is watching on YouTube. Create a dashboard. Do we have any? Okay. Yes, got it. Fine. Okay. Yeah, okay. Yeah, one viewer. Sure. He's okay. Well, we won't bother then. But, you know, you should definitely check out Adriana. Her stuff is rad. Her stuff is really rad. Or actually, maybe I will. Okay, how do I... Can I do it from my phone? I'd like to. There's a button for this somewhere. Oh yeah, okay, over here. Please. Okay. One viewer, we're going to go raid Booty Mashup. And yeah, okay, great.